We had seen how to add and subtract two rational numbers. So these are two rational numbers with same denominator. If the denominator is same, again the denominator remains same. All you need to do is add or subtract the numerators. So it would be p plus n or p minus n. Now if the denominators are not the same, then you can make the denominator same by either taking the LCM or just multiply them, which is q into n is qn. Then cross multiply pn plus minus mq. That's how you can add and subtract two rational numbers with different denominators. So we've seen addition and subtraction. Now what about multiplication? How do I multiply rational numbers? So let's look at this. Let's take a piece of paper which has a unit length. Now I divide it into half. This is half, this is half. I have divided this 1 into 2 equal parts. So each part represents 1 by 2. So I can say that this half plus half, half plus half would be, I know if I add two rational numbers with the same denominator, the denominator remains the same and the numerator gets added. So that would be 1 plus 1. Now 1 is being added to itself 2 times. 1 plus 1. Or I can say this as 1 added 2 times or 2 times 1. Repeated addition brings me to multiplication. So half plus half can also be said to be equal to 2 times 1 by 2. Now another way to see it is that half is being added 2 times. Half plus half. You are adding half 2 times and repeated addition gives me multiplication. So half plus half would be 2 times half. What I see is that 2 times half is the same as 2 into 1 by 2. That is, if you are multiplying a number with a rational number, what I see is that the denominator is remaining the same. That number gets multiplied by the numerator. So the denominator does not change and the number gets multiplied by the numerator. So if you have any number n, any integer, which is being multiplied by a rational number, which is of the form p by q, then n would get multiplied by the numerator, which would be n times p, and the denominator would remain unaffected, which is by q. So now let's say you have this sheet of paper, you are divided it into half. Now again you divide it into half. So you get this 1 by 2, 1 by 2. This is also half and half. Now I see that this piece of paper has been actually divided into 4 equal parts. 1, 2, 3, 4. Since one unit is divided into 4 equal parts, each part can be represented by 1 by 4. So I have that each part is equal to 1 by 4. Now, I know the area of a square piece is A times A. If you have a square which has the same side, all sides are the same, then I can say that area would be A times A. Now, again, in this piece, I have a square only which has half and half, sides as half and half. So area would be half times half. But I also know that this is nothing but 1/4 of the total portion, because I have divided this sheet, this 1, into 4 equal parts. And this is one of those 4 equal parts. So this is 1/4. So what do I get? That area is 1/4. I get that half times half is actually giving me 1 by 4. So now I know this, that half times half gives me 1 by 4. Now what the problem was, that whether it is, how is this denominator coming? Whether it is 2 plus 2 which is giving me 4, or is it 2 times 2 which is giving me 4? So there were two things that could happen. Either 1 by m into 1 by q. If I multiply 2 unit fractions, I could either get mq, which is m times q, 2 2s are 4, or I could even say that if I multiply two unit fractions, then I get m plus q as the denominator, which is 2 plus 2, which is 4. The numerator is not changing throughout. So, are the denominators being multiplied or are the denominators being added? That was the question. So, what we do is, we already had this sheet of paper which was divided into half. Now, what we do is, we divide it into further 3 equal parts. So, 1, 2, 3. Each part is 1/3 and this is divided into 2 parts. On the whole, I have divided this sheet into 6 equal parts. 1, 2, 3, 4, 5, 6. Now, each part represents 1/6. Again, if I try to find the area of one particular part, it would be 1/3 times 1/2. That would be the area of this portion. And this portion is also equal to 1/6. Each part is equal to 1/6. So what I can say is that 1/2 times 1/3 is equal to the area, which is equal to 1/6. Now there were two possibilities. Either 1/m into 1/q was giving me 1/mq. That is, the denominators were being multiplied. Or there was this question that whether the denominators are multiplied or added. 1/m into 1/q was 1/m plus q. Now, which of the two do you think is correct? What I can see is that the denominators are being multiplied. So, I know that 1/m into 1/q would give me 1/mq. This is satisfying the condition, hence is correct. If they were added, then 1/2 into 1/3 should give me 1/5, which is not the case. So, this is not correct. So, what I can conclude is that whenever I multiply two unit fractions, the denominators get multiplied and the numerator remains 1. Or you can say that the numerator is also being multiplied, which is 1. So, the numerator is not changing in case of multiplying two unit fractions and the denominators get multiplied. Now, the question was that what would n by m times p by q be? Now, that was the question. Now, again, I break it into whatever I know so far and I apply to find this. So, I can write this as n times 1 by m. Again, p by q can be written as p times 1 by q. Now, this I know would be equal to, since multiplication is commutative, about the multiplication sign, I can interchange the two numbers. So, look at this number here. 1 by m is being multiplied by p. So, since multiplication is commutative, I can change these two numbers. So, this would be equal to n times p times 1 by m. So, this would be changed. So, n times p times 1 by m times 1 by q. So, this is what I get. Now, I can club these two together. Since multiplication is associative, I multiply any two in any order, it does not matter. So, n times p would give me np. That is, multiplying two integers gives me another integer, which is np. Multiplying two unit fractions again gives me a unit fraction. Numerator does not change. The denominators get multiplied. M times q, mq. This is what I get. Now, what do I have? An integer which is being multiplied by a unit fraction. I know when an integer gets multiplied by a rational number, the integer multiplies with the numerator and the denominator remains the same. So, I can say this would be np times 1 by mq. Now, np times 1 would give me np only, denominator would become mq. So, this is what I get. So, if I have these two rational numbers and I multiply them, this is the result. That is, the numerators get multiplied, NP, and the denominators also get multiplied, which is MQ. So N by M times P by Q gives me NP by MQ. So now can you answer this question? Pretty easy. You just need to multiply the two numbers. What happens when you multiply two numbers? The numerators get multiplied by the denominators get multiplied. So you have this would be equal to, multiply the numerators, negative 3 times 2, which is negative 6. Multiply the denominators, 5 times 7, 35. So this is the answer, negative 6 by 35, or you can say this, negative 6 by 35. So we've seen how to multiply two rational numbers, any two rational numbers. Now let's see how do we divide two rational numbers. Let me recall that division was nothing but a reverse operation of multiplication. So let's look at this. If I multiply 3 by 2, I get 6. If I divide by the same number, I get back to 3. So now if I have n and I multiply it by q, I would get nq. If I divide this number by the same number, which is q, then I should get back to n. That is what division says, reverse of multiplication. So now let's look at this. We've seen that multiplying an integer by a rational number, the integer gets multiplied by the numerator, which is n times 1 n, and the denominator remains the same, which is n by q. So when I multiply n by 1 by q, I get n by q. Now if I reverse this back, that is, if I want to go back, what should I do? I should divide this by the same number, 1 by q. So I get this, that dividing by 1 by q, I get back to n. So look at this now. You have n by q, you divide it by 1 by q, you divide that by 1 by q. What do you get back? N. N. Now what I see is that n by q, when being divided by 1 by q, is giving me n. Or if I look at this, what should be multiplied to n by q to get n? So if n by q is multiplied by q, then I get n. And if it is divided by 1 by q, then also I am getting n. So what I can see, that division and multiplication are the same, but what is changing? The second term. Here I am taking the reciprocal of this term. So n by q divided by 1 by q is n. Also n by q times q by 1 is n. So dividing by 1 by q is same as multiplying by the reciprocal, which is q by 1. Let's take another example and see whether this works. So you have n, you multiply this by p by q, you get np by q. Now again you divide by the same number, which is p by q, you get back n. So what I see is that np by q, when divided by p by q, gives me n. This is same as multiplying by reciprocal it, q by p. So q gets cancelled. Again p would get cancelled. What I'll be left with is n. So whenever I have to divide two rational numbers, all I need to do is, it's similar to multiplication, but to convert this division to multiplication, the step is that you write the first number as it is, convert the division to multiplication, but as you convert this, the second number, the second rational number should be reciprocated. That is, p by q would become q by p. Now you know how to multiply two rational numbers. You multiply the numerators, which is nq, by multiply the denominators, which is mp. So this is how you can divide two numbers. Division can be converted to multiplication. Take the reciprocal of the second term and you know how to multiply. So we've seen that n by m divided by p by q gives me nq by mp. That is cross multiply nq by mp. So now let's look at these three different types. An integer being divided by a rational number being divided by an integer, a rational number being divided by a rational number. These are the three possibilities that can happen. Very easy. Write the first number as it is, convert division to multiplication, reciprocate this. This would be 2 by 3. 3 gets cancelled. Answer is 2 here. Let's look at the second one. The first number as it is, convert division to multiplication, reciprocate the second number, 1 by 4. This gives me 1 3 is a 3, 2 4 is a 8. 3 by 8. Let's look at the third number. First number as it is, which is 3 by 2. Division converts to multiplication and the second term gets reciprocated. 6 by 15. Now 2 3s are 6 and 3 5s are 15. So what I get is 3 by 5. This is the answer. So now can you divide these two numbers? Again, first number remains the same. Division would get converted to multiplication and you'll take the reciprocal of the second term, which is multiply the numerators. Negative 3 times 7 gives me negative 21. Multiply the denominators. 5 times negative 2 gives me negative 10. So this gives me 21 by 10. This is the answer here. So we've seen how to multiply and divide any two rational numbers.